Number one, how you gonna figure it out? E3 homework. How do you find out the unit rate? David. What are you gonna do? Unit rate. If you go up from 1, can you tell where it's at? Exactly. No. So let's go up from 2. At 2, what do you know? 5. So this is the rate. Okay, so you want to be thinking the rate is $5. We always have to put the Y first. So over on the board I have for rate. Remember, rate is always Y over X. So $5 per, not $5, 5, what are we talking about? Minutes? 5 miles. 5 miles per 2 minutes. That is my rate. It doesn't want the rate, it wants the unit rate, which means, Robin, I need to do what? We have to divide it. That means you're taking 5 and dividing it by 2, Robin, which leaves us with 2.5, right? 2.5, and we would say miles per minute. If you didn't have this down, please write it down now. Okay? Number 2, Kennedy. How are we going to find our unit rate? No numbers in this one. Yeah.
So you go to the first spot where the need,
The first spot where these lines meet. I agree. This is a nice point.
and then you find a norm.
Okay, can I go here?
No. You go
Okay.
there.
Use yours.
And then you count up.
Okay, how far did you count up?
3.
3. So we're talking about $3 going up, and then what?
Then you go over, and that's 2.
And over 2. Again, this is a rate. So my rate for this one is $3 per 2, in this case, pounds. That's my rate. But, Sammy, I want a unit rate. How do I get the unit rate?
And divide
Okay, and get what?
1.5.
$1.50 per 1 pound. Okay? We're looking at the next one, Brooke, number 3. Unit rate.
If you
How do you find it? What are you going to tell us?
go to the dollar ranges,
3, 2. So we got this point, 3, 2. Okay? 2 divided by 3. Because we look at our cost, this is our Y. Our cost is $2. That's my Y. So we have $2 for my rate per 3 pounds. And the most confusing thing that I think students do at this point is they take the first number that they see and they put it in their calculator and they go 3 divided by 2, the answer has to be 1.5. And it is wrong. The answer I would either take is either 66 cents or 67 cents per pound, because you are dividing exactly as Brooke said, 2 by 3. Okay. Now let's take a look on the top of the next page at number 4, 5, 6. So number 4. Okay. Christelle, when we look at number 4, what is if we're going to look at the unit rate, how are you going to do it? It's kind of like the one we already did, like number 2. Yep. The point where the line connects, does it matter which one? Can I go here? Okay. So the first one, am I looking at this one?
Yeah.
Okay. And then where'd you use for the next one? Way up here? Way up here? Is that look about right? Yeah. Okay. So if I'm looking at that point, first thing I want to do is I look at that. Tell us, what is my, how does the Y change? How did it go up? How far? Went up 3. So that's my 3 miles. So when I go to do just my rate, and if you don't have this down and you didn't do it, I'm helping you out here, right? This is part of your homework. 3 miles. And then, Kristen, I'm going to have what? And we went over 4. So I should have over 4 minutes. But I don't want to leave it like that. Greta, how am I going to leave my answer for the unit rate? Okay. So I could have 0.75 miles per hour. Could I leave it as 3/4 of a mile per hour? Same thing, right? All right, Noah, we're looking at number 5. When you look at this equation, what do you know the unit rate is in that equation? $4. If you don't have this down, please write it down. $4 per pound. Because the question said, do the graph and the equation have the same proportional relationship? Keep in mind, to be proportional, it has to start at this point 0, 0. Okay? And then it has to have a constant rate of change by adding or subtracting. We're going to fill that in our notes a little more today. So, I look at the graph. Devin, what is my rate of my unit rate for the graph? 5. How'd you get 5?
Because I looked for the 2.
Okay.
And I went up and I got 10.
10 divided by 2. So on this one, our unit rate was actually $5, okay, per pound. So once I have these two, I can actually answer the question. Do they have the same proportional relationship? No. On the test, I'm going to ask you a why. I am not going to leave you on this big quiz. And by the way, the big quiz is going to be moved to Monday. Because today, by the time we get through the test reflections, we're not going to have enough time doing that and finishing all the notes. So tonight's assignment, that's why when you look at the board after the last class, we only have a few questions that you're doing in tonight's. And the other thing is that we are not going to hand in the E3 today. I'm going to go through the rest of the answers on this page, but those of you that are getting behind, I am looking at doing an email to you and your parents saying, hey, I'm already missing this year 2 or 3 assignments, or I need to get this from them. So if that happens to be you, or you're getting back assignments and you're not getting all the points on them, meaning you hand it back and it's not quite clear or you're not getting all the points, make sure you're checking with me. So, number 6. Does it tell you what scale to use at all in number 6 to graph it? Does it tell us a scale? No. So, what if you don't have a label here? You need to tell me what you're talking about. This is where I usually take off points here and there, and people go from an A to a B on a quiz because they don't tell me what this is. They just put the numbers. They go, oh, this is 1, 2, 3, 4. Great. This is 1, 2, 3, 4, 5. And so I see this. Now, some people decided to go up by 5. I need labels. So what were we talking about here? We were talking about our cost. What kind of cost? In dollars. What are we talking about here? We're talking about the pounds of salad, right? So this is going to be our weight. If you are not doing these and putting labels with them, I need those, okay? Depending if you would have graphed going up by 1s, your graph would look something like this. I had someone in this morning, we were working, they went up by 5s. They had 5, 10, 15. Their graph looked like this. Both are correct, okay? You could have gone up by 2.5 each time. I don't care. You have to have a constant scale, but I don't care if you go up by 1s or by 5s. I need to see your graph, and I need to know what you're talking about. So besides having the numbers, having this part. As you look at those last questions, any problems on 7 through the rest of this that I could answer? 7 through that back page. Are there answers in the back for these?
No.
For what? Yes?
Yes. I do want you to use those answers in the back. So check them and make sure before you come in tomorrow and you hand it in. Because there's a lot of people's E2 that you handed in and E1 and it wasn't right. You gotta check, okay? All right. Please right now on your notes today, but we're still working with that unit rate. Right now, I want you to turn to your shoulder partner and come up with at least 3 different real world rates. Places where you see it. So, one that we've seen already is like in a grocery store, right? Dollars per pound when you buy something. Talk with your shoulder partner and give me at least 2 more because I'm going to call on you and just cut their arm.
One sign per whiteboard.
Okay. You 2 are with him. So you're going to this one. So you're going with the not turn around to the people behind you. All right, who's ready? Raise your hand. Who has one for me? Another one. Ooh, Sophie.
There are 654 wildcats per wall.
In this room, the wildcats that are up, wildcats per wall. Okay? Give me another real world rate. One that you see more often.
That's
Yeah.
miles per hour.
Miles per hour. Another one. $1 per pound, so we already got that one. How about in science? You're doing an experiment, right? You might be measuring the temperature, right? Temperature change. You guys did that this year. So temperature per minute, right? Every minute you were timing it and doing something like that. Any other real world rates? Okay. So thinking about that, you actually will see them, if you think about it, there's many places that we see rates, okay? Right now, we are going to look at this situation. Most people earn money by working. The amount of money that people are paid varies. Some are paid by the hour, others yearly salary. How often people are paid also varies. For example, I'm a monthly employee. I get paid once a month. There's many people that get paid weekly or a couple of times a month, every 2 weeks. So depending on that. So it says, how could you compare the income of 2 workers based on their paycheck? What would be something you'd need to know if you're going to compare how much money they're making? One thing, Sammy, might be what?
What? Wait, never mind.
No? Greta, do you have something? How could I compare them? What do I need to know? How much they do make. And when we talk about that, we're going to need to know the dollars that they earn. And we want to know what time period, right? For a certain time period. If it's per hour, if it's per day, if it's per week, right? We're going to need to know how much they earn in a pay period, right? In order to compare them. So if I was comparing how much I made to someone else, if I'm working at a restaurant or someplace, I need to know how much we're both making, right? In order to compare them. So it says, how can a worker find out how much he or she earned in a certain time? Any of you have jobs babysitting? Ever have a job babysitting? And you leave babysitting and the people go, here's $30. Is this okay? And you've been there for 5 hours. And you might say, yes or no, I don't know. But if we get paid, if I get paid in this case $30 and I've been babysitting for 5 hours, can I find out how much I'm making per hour? Yeah. I'm going to take the $30, right? And divide it by 5 and go $6 an hour. Wow. All right. They might say, here's $30 and you've been there for 2 hours. They're pretty happy then, right? That's a nice payday. Some of you, anyone shovel? Do shoveling for anyone? If you're shoveling and getting paid, if it takes you only a half an hour one time and then it takes you 2 hours the next time and they say, I'm just going to pay you $25 a time, I mean, you're happy when it's a half hour that you had to shovel, right? So it's important that we know per hour. So we're going to look at some of these different questions as we look at this. So here, turn to the top of the next page. We have this employee list. She's a temporary employee. Last week she worked 20 hours and earned $300. We're going to use this information to find more about her rate of pay. So right behind pay, we want to put down how much was she paid, and in our case, she was actually paid $300, right? So we're going to put the dollar sign with it, 300, over 20 hours. That is her rate. It's a ratio of numbers. Remember, a ratio from the beginning of the year is simply one to another. So it says this week, Lacey earns $35. Use your ratio and write and solve a proportion. You guys did proportions last year. Proportion is when you put two fractions equal to each other. So we're going to put two fractions equal. What's the first fraction? $300 to 20 hours. Now, if we are working 35 hours, should I put the 35 in the numerator with the dollar sign or in the denominator? In this case, Adam, what are you thinking? Where should I put 35 hours? Numerator or denominator? Numerator. Up on top here? Yeah. Does that go with the $300? Oh, no. I want to keep my units the same, so I'm going to put the 35 hours, right, in our denominator, okay? I have no idea how much money I made. I made X. Anyone remember from last year how you solve a proportion? What do you do with the multiplying across? Kenny, you remember?
Yeah, you multiply.
We're going to multiply across this way, right? So 20x equals, what are you going to do on this side with these two numbers? No, we're going to multiply 35 times 300. Please do that right now. 35 times 300. You can use your calculators. 20x equals 10,500. But I want to know per one. So solving our equations, I'm now going to divide both sides by. You remember doing this last year?
We did it this year.
Yes, we did do it this year, but you did it last year quite a bit, proportion, okay? So what do I get for an answer? $525 for 35 hours of work.
Wait, I have an easier step.
Okay, that's good. We're not going to look at that right now because we're going to do it a different way soon, okay? So it says next week she earns a total of $40. So if now we have $40 that we are working, 40 hours that we're working, we want to set up a different proportion. Now, we're going to use the same one to start. We're going to go with 300 over 20. This is my hours. Put in your labels, just like in science. So Devin, where do I want to put the 40? Numerator or denominator? Denominator. Now this time, instead of doing that cross multiplying, I might notice, what do I take times 20 to get 40? Times 2. So I can simply take 2 times 300, and I didn't know what this is, but 300 times 2 gives me 600. Does that make sense? I worked more hours, $600 in 40 hours. Here I had 35, okay? So I had $600 in 40 hours. Okay, so that's like working for the week if you were getting paid that rate. And now at the top of and that next screen down, we want to take a look at what was her unit rate. So we're going to take our 300, remember that's what it was, 300, and we were working how many hours initially? 20. So please take 300 and divide it by 20. Our unit rate is going to be in dollars per hour, and we're going to say she makes $15 per hour. Right? That's one way of writing it. Here's the other way. Put your 15, put your fraction bar over 1 hour. The last way, those are generally the ways that we are going to be looking at that. So it says Lacey works 8 hours in one day. And the question is, this was supposed to be moved up. It got moved on my screen. And the question says, how much money does she make in one day? So if she works 8 hours, We already saw the answer. Show me how you should get that answer. What should we be doing to get that answer? We should be taking 8, right, hours, times our $15 an hour, and 8 times 15 gives us 120 a day. Now, this next part is the part that's pretty important that we want to take a look at. It says, if we were to model Lacey's pay on a table and a graph and an equation, how would it show differently? And this is pretty important, and this is where, like when you do your homework tonight, if you need to come back and take a look at this, this is kind of important that I want you to take a look at. When we look at a table, in a table, it's the numbers in the Y columns seem to be going up by 15. That's how we would know in a table. And I want you to make a table right behind this. I want you to make an XY table where this is our hours and this is our pay in dollars. And at 0, we get paid 0. And after 1, it would have been 15. And at 2, it would have been 30. And at 3, and we could keep going and making that table, right? And when I say the numbers in the Y column keep going up by 15, that means as I go from one to the next, I notice that I am adding 15 each time. So you're going to see in your homework in the next few days a table. And I'm going to say, what's the unit rate? The unit rate is as this increases, as X increases by 1, how does the Y change? Change by 15. It says on a graph, it's the line pattern that I notice it goes up by 15 as you go over 1. So that if I'm looking at my graph, right, here's my Y, here's my X, and as I look at that graph, that means I go up 15, right, this is my 15 that I go up, and I go over 1 unit. That's what that rate looks like on a graph. So depending on your scale, right, if you have going by 1s here, or if you have going by 5s, you have to count how much you go up by. That's why sometimes when some of you set your scale going by 5s, you got to remember, if you go by 5s, this would be 5, 10, 15. And this is just 1. And then the last one is the equation has a Y in it. And I want you to change this and not just put an equation has a Y in it behind that word equation. I want you to put the equation would have 15 times the independent variable. Which one is independent? X or Y?
Y. X.
X. X is independent.
Y.
Okay? Times the X. So this is what the equation would look like. Y equals 15X. And that's where our unit rate is in an equation. This is where the unit rate is in a graph. This is how you see the unit rate in a table. Now, we are not going to finish the rest of the notes. So make sure you have this down before I change the screen. And what you are going to do, and then tomorrow we will kind of